Okay, in an earlier video, I discussed the unit circle and we discussed the degrees and the radians. In this video, I want to discuss this ordered pair, the cosine and the sine. So let's continue working. Okay, so here we have the unit circle. And of course, this is 1 unit. So from my origin, the point 0, 0, this is the point 1, 0, and this is the point 0, 1, negative 1, 0, and 0, negative 1. Now, in a circle, you know that we have lots of radii, and all of these are 1. Now, we are wanting to learn about the cosine and the sine, the ordered pair that's associated with points on the unit circle. So we have just said all of the radii are 1, and I am going to use right triangles to help me work with the unit circle. So in this right triangle, my hypotenuse is one of the radii. It must be 1. And from this point, I can drop a perpendicular line to the x-axis, and I will have a right triangle. I can use right triangles to help me find the coordinates or the cosine and the sine of many points on this unit circle. Let's get to work. Okay, so let's review a little bit. Remember the 30-60 right triangle? Do you remember that we had a short side? The short side was across from the 30-degree angle. The long side was across from the 60-degree angle. And we had the hypotenuse. Well, I am using these right triangles in my unit circle. And my hypotenuse is going to be one of my radii, which is 1. Now let's review again. The hypotenuse was twice as long as the short side, which means the short side is half as long as the hypotenuse. And also, do you remember that the long side was the square root of 3 times the short side? Well, multiply straight across. That will be the square root of 3 over 2. So the short distance is 1/2, and the longer distance is the square root of 3 over 2. We will be using that a lot. I have a unit circle here. And I am wanting to know the cosine and sine of this point. And I am telling you that this is at 30 degrees. Remember 30 degrees? That is the radian, pi over 6. Well, I'm going to use a right triangle to help me. I do know that this is 30 degrees. And if I drop a segment from my point to the x-axis, I have a right triangle here. In order to get to this point, I had to go to the right the long distance, the square root of 3 over 2, and then I had to go up the short distance, which is 1/2. This is the point, the square root of 3 over 2, 1/2. Or the cosine is the square root of 3 over 2. The sine is 1/2. What about 150 degrees? Well, I'm going to use a right triangle to help me. Now, 150 degrees is just 30 degrees before 180. So I do drop in a 30-degree right triangle. So this is the long side. Now, I know that distance is always positive, but the reason I have negative square root of 3 over 2, because I will be going to the left in my coordinate plane to get to this point, and then I will be going up the short distance of my 30-60 right triangle, which is 1/2. So this point is negative square root of 3 over 2, 1/2. Or the cosine is negative square root of 3 over 2. The sine is 1/2. So what about 240 degrees? Well, 240 degrees is 60 degrees more than 180 degrees. I'm going to drop in this right triangle to help me. That is 60 degrees there. So I will be going left the short distance, which is -1/2, and then I'll be going down the long distance. So that would be a negative square root of 3 over 2. At 240 degrees, the cosine is -1/2. The sine is negative square root of 3 over 2. 240 degrees is also known as 4 pi over 3. These are my angles that increase by 30 degrees. Now, of course, all of the ordered pairs, or the cosine and sines that are on the x and the y-axis, they're all made up of 0, 1s, or -1s. Look at all of the cosines and sines for the other angles. They are all made up of either 1/2 or the square root of 3 over 2. Some are positive and some are negative. Feeling good? Let's keep working. The 45-45 right triangle. Once again, we are using a hypotenuse of 1 because we will be using this triangle to help us in our unit circle. Now, in a 45-45, if the angles are congruent, then the sides opposite them are also congruent. Remember, a squared plus b squared equal to the hypotenuse squared. In this case, one leg squared, which is x squared, plus the other leg squared, another x squared, is equal to 1, which means 2x squared is equal to 1. Divide both sides by 2. I will take the square root of both sides, and x will equal to the square root of 1 over 2. And the square root of 1 is just 1. Of course, we don't want to leave a radical in the denominator, so I will rationalize the denominator. X is the square root of 2 over 2. This is a very important number for our unit circle. And now we're going to talk about the cosine and the sine of angles that increase by 45 degrees. 45 degrees, here we are. This is the radian pi over 4, and I am going to use a right triangle to help me out. In order to get to this point, I am going to go to the right, the square root of 2 over 2, and I'm going to go up the square root of 2 over 2. The cosine and the sine are the same. They're both the square root of 2 over 2. What about 135 degrees? Well, that is just 45 degrees above 180. I do have this right triangle to help me out. In order to get to this point, I am going to go to the left. So I will say negative square root of 2 over 2, and then I'm going to go up the square root of 2 over 2. The cosine is negative square root of 2 over 2. The sine is the square root of 2 over 2. So here are our 45-degree angles. So on the x and the y-axis, I still have sines and cosines of 0 and 1, or a -1. But notice the other cosines and sines. They are all a combination of the square root of 2 over 2. Some are positive, some are negative. So here are all of my cosine and sines in my unit circle. Look at the first quadrant. In order to get to any point up here, any point, I would go to the right. So do you notice all of these cosines are positive? And I would go up. Do you notice all of the sines are positive? Look in the second quadrant. In order to get here, I would be going left for the cosine. And sure enough, all of these cosines are negative. And then I would go up. So all of the sines are positive. In the third quadrant, I will go left and then down. So the cosine and the sine are both negative. And in the fourth quadrant, I would go right and then down. So I have a positive cosine and a negative sine. This is a similar picture, but instead of our degrees, we have the radians pictured. So in the first video, we talked about the degrees and the radians in a unit circle. In the second video, we have talked about the cosine and the sine that's associated with those degrees and radians. I hope you have a great understanding of the unit circle.